Hi there, welcome to the video guys. My name is Pushpinder Gill and today we are going to talk about the principle of mathematical induction. So we're going to be talking about mathematical induction, right? So before we get started, I hope you know about our web address, that is perfect-scores.com. This is there to explore more about us. Our Facebook page, you can give us your valuable like at facebook.com/perfectscores. And don't forget to send us your valuable feedback on perfectscores89@gmail.com. So let's go ahead and get started with the principle of mathematical induction. So before I start, I'll just like to start with a very simple example. There are many ways by which you can use math. Basically speaking like that. So you can actually deduce something, or that is known as the process of deduction, and then there is a process known as induction. Now what's deduction? Deduction means, let's suppose if I say that sum of first n odd natural numbers, so sum of first n odd natural numbers is n square. So from here I deduce that sum till first 50 natural numbers is going to be equal to 50 square, right? So sum till the first 50 natural numbers is going to be 50 square. However, induction works completely in an opposite direction, right? So what happens in induction is that let's suppose if I say that 3 into 3 plus 1 is actually an even number. I can also say that 7 into 7 plus 1 is also an even number. So from here I can induce that n into n plus 1 is always going to be an even. So in deduction what we do is we have the general form of the formula or the expression, and from the general form we kind of take examples. And induction what we're doing is we're actually using these examples to come to the general form. So that is what induction is, right? So in this video we're going to be talking about the principle of mathematical induction. That's the way for you to prove these formulas. Now what's the formal way? What's the most formal way for you to actually use this formula or to actually use this principle of mathematical induction? So let's go ahead and learn that. So I'm going to be talking about the principle, the formal or the technical proof of principle of mathematical induction. So principle of mathematical induction states that let's suppose P of n is actually a statement. Now statement can be anything. The statement can be that let's suppose that n into n plus 1 is always going to be an even number provided n is a positive integer, right? So P of n is it actually can be any statement. So when I say statements, I hope you watched the statement videos in that you understood what is actually a mathematical statement. A mathematical statement is something which is a fact, which can either be true or which can either be false, right? So this actually is a mathematical statement in which this statement turns out to be true. Now the question says that there are few, the principle of mathematical induction says that few of the restrictions or few of the conditions have to be true. The first condition is that P of 1 is supposed to be true. So the P of 1 is actually something that's supposed to be true. So what is P of 1 here? So P of 1 over here is 1 into 1 plus 1. Is 1 into 1 plus 1 an even integer? Yes, it is, right? So that's the first restriction that should be followed. And the second restriction that should be followed, or something that kind of a statement here, that the truth of P of k, that means if P of k is true, that will automatically imply that P of k plus 1 will be true, and that is by the principle of mathematical induction. Now when I talk about P of k and P of k plus 1, what I'm trying to say here, let's suppose if I take an example, let's suppose if I take a logical example that this n into n plus 1 is even, for all positive n integers, for all positive integers, n can be any positive integer. If this is actually true for k and k plus 1, this will also be true for k plus 1, if you substitute, and k plus 2. This will also be true for k plus 2 and k plus 3. So that is what the principle of mathematical induction is, that if it's true for this and if it's true for this, it is going to be a valid statement, right? So if it's true for this and it's true for this, it's going to be a valid statement. See, I don't need to be checking, I don't need to plug in n to be equal to 1 and check it here. I don't need to plug in n to be equal to 2 and check it here. I don't need to plug in n to be equal to 3 and check it here. All I can say is, let's suppose if it's true for k and it's true for k plus 1, that means from k to k plus 1, this expression is holding true. This is something which is going to be true all the time. So that is what the principle of mathematical induction states. And so always there are going to be two steps. This is going to be your basic step. When I say basic step, you're gonna, whenever you get an expression or anything like that, first you're gonna make sure that the p of 1 is true, and then after that, this is going to be the inductive step. In the inductive step, you're gonna say if it's true for p of k, it has to be true for p of k plus 1, right? So let's actually go ahead and start with the question here. Let's suppose the question is that this is actually the statement that we have to prove that the product of two consecutive natural numbers is even, right? So this is something that we have to prove using the principle of mathematical induction. So what I'm going to do here is, first of all, I'm going to perform the basic step, right? Now basically the question wants the product of two consecutive integers is actually even. So will p of 1 hold true? That is going to be 1 into 1 plus 1, which is equal to 1 into 2. Is that an even number? Yes, that is an even number. That means this is true for the basic step. Then what we're going to do is we're going to actually perform the inductive step. So when I say the inductive step, if it's true for p of k, it has to be true for p of k plus 1. So when I say p of k, that is equal to k into k plus 1 is actually even. Now what do I have to do is, I have to prove that it's true for k plus 1. So instead of k, or instead of n, I will substitute k plus 1. So if I substitute k plus 1 into this, I would get, instead of n, I'll get k plus 1. And instead of n plus 1, I'll get k plus 1 plus 1. So that is going to be equal to k plus 1 into k plus 2. So I have to prove that this over here is actually an even number. So from here I can say that there are two possibilities, two possible value for k. K can actually be an odd number, or k can actually be an even number. So if k is odd, then odd plus 1 and odd plus 2, that is something I'm going to get from here. Odd plus 1 is going to be an even number, and odd plus 2 is going to remain an odd number. Even into odd is even. Similarly, when k is an even number, even plus 1 into even plus 2. So even plus 1 is going to be an odd number, even plus 2 is going to be an even number. That is again going to be even. So that means every time k plus 1 and k plus 2 is actually going to be an even number. That is, this is something that I've actually proved with the principle of mathematical induction. That means I've said that if it's true for k, it's true for k plus 1 as well, which means by the principle of mathematical induction, I've proved that n into n plus 1 is always going to be even, right? So I suppose you're understanding this point over here, guys. Let's try another example here. Okay, so this question over here says that by principle of mathematical induction, prove that 1 plus 2 plus 3 plus 4 all the way till n is equal to n into n plus 1 by 2. So what I'm going to do is I'm going to actually work out the first basic step. So what's the basic step? The basic step is that p of 1 that is the sum till 1 terms, which is actually equal to 1. Is that equal to n into n plus 1 by 2? Now n is actually equal to 1 here, so that is going to be equal to n into n plus 1 divided by 2, which is equal to 2 divided by 2, which is equal to 1. That means 1 is equal to 1. That means I've proved the basic step. Now it's my time to go ahead and do the inductive step. Now what's the inductive step here? Inductive step says that if it's true for k, it has to be true for k plus 1 as well. Now, what do you mean by k? So when I say it's true for k, that means 1 plus 2 plus 3 plus 4 plus all the way till k is equal to k into k plus 1 divided by 2. And that is something which is a fact. That is something that we have taken it to be true. Now we have to prove that 1 plus 2 plus 3 all the way till k plus 1 is equal to n into n plus 1 divided by 2. So what is n? N is k plus 1 into n plus 1, which is k plus 2, divided by 2. So that is something that we have to prove, and we have to use an algebraic approach here. We cannot just plug in numbers, because actually we're trying to prove it with the principle of mathematical induction. Now if you see here 1, 2, 3 all the way till k, before k plus 1, k is going to be there. The sum on this is already equal to k into k plus 1 divided by 2. So what I'm going to do is I'm going to substitute this. I'm going to write k into k plus 1 divided by 2 into k plus 1. Sorry, it's not into k plus 1, it's plus k plus 1. So if I just focus on the left hand side here, so that is going to be k into k plus 1 plus, if I take this 2 to that side, that is going to be 2 into k plus 1 over over 2, right? So that is going to be, if I take k plus 1 and k plus 1, something common from both these terms, I'm going to have k plus 1 into this k, and this 2 is left out. That means k plus 2 divided by 2. That is something which is equal to the right hand side. So that means I've proved the inductive step as well. I've proved that if it's true for p of k, it has to be true for p of k plus 1 as well, which means I can say that by principle of mathematical induction, by the powers vested in me by the principle of mathematical induction, that 1 plus 2 plus 3 plus 4 all the way till n is going to be equal to n into n plus 1 divided by 2. So I suppose you're getting this point here, guys. Let's go ahead and try a difficult question now. Let's move forward. Now let's go ahead and do this question here. So the question says that by the principle of mathematical induction, prove that 1 into 3 plus 3 times 5 plus 5 times 7 all the way till 2n minus 1 and 2n plus 1 is equal to n into 4n square plus 6n minus 1 by 3, where n belongs to natural numbers. So what I'm going to do is the same old story. I'm going to start with the basic step first. So basic step is asking me to make sure that the p of 1 is true. So when I plug in when I say the number of terms is equal to 1, so the first term is just 1 into 3, that is supposed to be equal to this expression in terms of n. So instead of n, I'm just going to substitute 1 here. 1 into 4 into 1 square plus 6 into 1 minus 1 divided by 3. So that is going to be equal to, if I just focus on the right hand side here, that is going to be 4 plus 6 minus 1 divided by 3, which is going to be 10 minus 1 divided by 3, 9 by 3, that is equal to 3. So I have proven that the left hand side is equal to the right hand side, which means the basic step is fine, it's complete. Now the next step that I have to do is I have to do the inductive step here. In the inductive step, I have to say that if p of k is true, that if it's a fact, then p of k is also true. I have to prove this up, this thing here. So that means the fact that I have with me, something that is true, that 1 into 3 plus 3 into 5 all the way till 2k minus 1 into 2k plus 1 is going to be equal to k. So instead of n, I'm going to have k here, 4k square plus 6k minus 1 divided by 3. Now, what do I have to do is I have to prove that 1 into 3 plus 3 into 5 all the way this step here plus one extra step. So that is still k plus 1. So another step that is going to be 2 into k plus 1. Instead of k, I'll have k plus 1 into 2 into k plus 1 plus 1 is equal to when I talk about the right hand side here, so I'm just gonna write the right hand side here. Instead of k, I'm gonna have k plus 1. That is k plus 1 into, so instead of k, I just have k plus 1. 4 times k plus 1 whole square uh, plus 6 into k plus 1 minus 1 divided by 3. So that is what I have here. So what I'm going to do is, again, I'm just going to manipulate a little here. I have to prove that this is equal to this. So I'm going to, instead of all these numbers, I'm going to write this expression here, because at the end of the day, this is the fact that we have. So what I'm going to do is, instead of this, I'm going to write this. So, I'm just going to do the left hand side with a different colored pen here. Let's pick up yellow. So if I talk about the left hand side, that is going to be equal to k, so this is k, into 4k square plus 6k minus 1 plus this thing here, which is going to be 2 into k plus 1 uh, 2 into k plus 1 minus 1. So that is there, that is 2 into k plus 1 minus 1, again multiplied by 2 into k plus 1 plus 1. So what I'm going to do is I can actually so this thing over here is actually divided by 3, right? So if I kind of open this thing up, so it's going to be, so I'm just going to take this 1 by 3 out, and this over here, it's going to be 4 into k, which is 4k cube, plus k into 6k, which is 6k square, into a negative of k, then minus of k, plus then what we're going to have here is we're going to keep this, since we've taken 1 by 3 out, we've taken 1 by 3 completely out, so I'll have to take 1 by 3 out from here. So I'm going to say, let's suppose this is 3 by 3, so I'm taking this 1 by 3 out, which means 3 is going to be left here, and then I have 2k into k plus 1 into 2k into k minus 1. So if I kind of open this up, I'll be left with 4k square plus 8k plus 3. So if we kind of solve this up, so that comes out to be 4k squared, because this is nothing but 2k, 2k plus 2 minus 1, and this is nothing but 2k plus 2 plus 1. So if you open that up, this is what you get. So this is nothing but your left hand side. Now what about the right hand side? Now the right hand side, so I'm just going to use a different color pen for the right hand side here. So let's just use white only. Fine. So for the right hand side, if I talk about the right hand side, which is this, that's gonna be equal to 1/3 that is already out, which was the reason I took 1/3 out, because 1/3 is actually out there as well, and I have k plus 1 multiplied all throughout. So what I'm gonna do is I'm gonna multiply k plus 1. And again k plus 1 gets multiplied here, so k plus 1 into k plus 1 whole square, so that is something which is there, and so that is going to be 4 into k plus 1 whole square plus 6 into k plus 1 minus. So I'm going to take one more k plus 1 out, so I'll have k plus 1 whole square over here, so over here I'll have 4 into k plus 1, which is 4k plus 4 plus 6 minus 1, so that is already there. Okay, I'll just rub that out a little. Okay, so 1/3 is out, and you have k plus 1 outside, and if you open this expression up, you're gonna have 4k square plus 8k plus 4, and if you open this expression up, you're gonna have 6k plus 6 minus 1. You definitely have the 1/3 out here. So if you kind of rearrange this, that is 1/3 of k plus 1 into this. If you kind of rearrange this, you're gonna get 4k cube plus 18k square plus 23k, and plus 9. So that is what you get from here. And if you kind of substitute this, rearrange this, the left hand side is going to come equal to the right hand side. I'll leave this little bit of manipulation to your end as well. So I have proved the inductive step as well, which means by the power vested me by the principle of mathematical induction, I can say that this whole expression is actually, the sum of this whole expression is actually going to be equal to the sum of this whole expression, right? So at the end of the day, the principle of mathematical induction, it's quite simple. The only thing that you have to get used to is kind of this manipulation of algebra that you have to do in every question, right? So make sure that you separate the left hand side from the right hand side and you try to work your question. Manipulation is very, very important because you cannot just plug in numbers. We are not doing this for objective questions. See, if this would have been an objective question, a question with a multiple choice, then we would have simply plugged in numbers and tried to prove this. Plugged in n equal to 2, n equal to 3, n equal to 4. Fine, it's working for n equal to 1, 2, 3, 4. It's working everywhere. However, if you want to get some marks in your subjective exam, you'll have to write all these steps, right? So I was actually lacking a little bit of space here, which is why I stopped here. But once you manipulate this, you'll get the left hand side to be equal to the right hand side, right? So I suppose you're understanding this video here, guys. So thank you very much for watching this video. This was the video on principle of mathematical induction. This was just the basic part of it. I hope you've understood everything what I'm trying to explain here. So this would be the website to explore more about us, that is perfect-scores.com, and this would be the Facebook page to give us your valuable like, and this would be the email address where you can give us your valuable feedback. So this would be about the video, guys. Thank you very much for watching, and I'll see you.